Hello students, so today I'll be taking a small topic, squares and square root, how to find the squares of a square of any number and how to find square root of a number. Okay. Okay. So square means multiplying the same number twice. Okay. To multiply the same number two times. For example, 17. 17 square will be 17 into 17, that is 289. Okay, so let us write squares from 1 to 20. So 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16, 5 square is 25, 6 square is 36, 7 square is 49, 8 square is 64, 9 square is 81, 10 square is 100. Okay, then 11, 12, 13, 14, 15, 16, 17, 18, 19 and 20. So 11 square is 121, 12 square is 144, 13 square is 169, 14 square is 196, 15 square is 225, 16 square is 256, 17 square is 289, 18 square is 324, 19 square is 361 and 20 square is 400. Okay, now there's one thing to observe. The square of 1 and 9 lasts with 1, means the unit digit of the square of 1 and 9 will always end with 1. The unit digit of 2 and 8 will end with 4. The unit digit of 3 and 7 will end with 9. Okay? And the unit digit of 4 and 6 will end with 6. Fine. And always the unit digit of 5 will always end with 5. Now why have I told you this? I'll tell you after a few minutes. Okay? Now these are small numbers, 2-digit numbers, wherein you can just traditionally multiply the number and find the squares. But what when the number is bigger? Like for example, 101. So instead of traditionally multiplying it, what will I do? I will use the identity. Okay, a plus b whole square. So a plus b whole square is a square plus 2ab plus b square. So can't I write this 101 as 101? Okay, so this 100 will be a, 1 will be b, and I will just put the value in the given identity. Okay, so this is 100 plus 1 whole square, that is 100 square, plus 2 into a is 100, b is 1 and b square will be 1 square. So 100 square will be 10,000. 2 into 100, 200, 200 into 1, 200. Okay, and 1 square is 1. So I will simply add this 1, 0, 2, 0, 1. Okay, so this is my final answer. So 101 square will be 10201. Okay, now if I'm asked to find the square of 99, so instead of now if you apply the identity of a plus b whole square, you will have to split it into 90 and 9. Okay, but that will still be a lengthier process. So instead of that, I will use 100 minus 1. Okay, so applying the identity of a minus b whole square, a minus b whole square is a square minus 2ab plus b square. So a is 100, b is 1. So this is 100 minus 2 into a is 100, b is 1 whole square. So 100 square is 10,000 minus 2 into 100, 200, 200 into 1, 200 minus 1. So what will be my answer? So this will be 9801. Simple. Okay, so I just need to subtract the values. That's it. So you can use the identity as well to find the square of any number. Okay? Similarly, just for your practice, you can solve few questions like 599 square, then 603 the whole square, 1003 the whole square. So you just need to use the identities and do the process. Okay. Now, let us switch to the next topic, that is how to find the square root. Now, for example, so if I am writing under root 16, so this is very easy. 16 is the square of 4. Okay. If I am writing under root 25, this is the square of 5. Okay. If I am writing under root 100, this is the square of 10. But if I am given a bigger number, what will I do? Let us say, for example, 5776. Now, I am asked to find the square root of this number, 5776. So, there are two methods to find the square root. Okay. One is the long division method. And another is prime factorization. Okay. Either of the methods can be used to find the square root unless it is mentioned in the question. If it is given in the question that you have to use the prime factorization or the long division, only then you are restricted to one method, else you can use any one of them. So now, first I will solve it with this long division. Okay. Now, okay, so 5776 by long division method. So what is the procedure? So the first step is from the right hand side, from the ones digit, make pair of 2. Why 2? Because we are talking about squares. Okay, so I have made the pair. Now I have to check whether 57 is the square of any number. Is 57 the square of any number? No, it is not. So, I need to find a number which is less than 57, closest to 57, which is a square. So, below 57 it is 7 sevens are 49. Okay, so 7 sevens are 49. Understood? So, Subtracting 57 with 49, what will I get? So 1 and 8, this is 8, okay. Then these two numbers will be taken down. Next step is, whichever number you have written on the left hand side, you need to add the same number and write it over here. The number should be same. If here it would have been 8, you would have written 8, okay. Now here it is 7, so 7 plus 7, 14. Now the next step is, you have to write a digit over here. This should be same written over here, okay, and you have to check whether it is either the number should be exactly 876, which is the given number, or it should be less than that. So we will check. So this and this digit should be the same. Checking 141 into 1 is 141, very far from this. Checking 142 into 2, 2 2s are 4, 2 4s are 8, 2 1s are 2, 284, again it is far, okay. 143 into 3 is 429, 144 into 4 is 576, okay. 145 into 5 is 725, 146 into 6 is 876. Here I got the answer, okay. So this is 146 into 6 is 876, okay. The remainder is 0. Means 5776 is the square root of 76, okay. Under root 5776 is 76, okay. So this is the method and it's called long division method. With the help of long division method, I can find the square root of any number. Okay, one general question is that this is a 4-digit number which I gave. If I would have given a number which has 5 digits, say for example 15625, so how will I make pairs? In a similar fashion, I will make pair of 2, and the one which is remaining will be considered as 1 only, okay. You will not have to write 0 or any other number, fine. Now using the same number, okay, I will tell you the method of prime factorization, okay. So the method of prime factorization means the L method, or how you find the HCF or LCM, okay. So 5776, so now we will factorize it. So if I divide this number by 2, so 5776 divided by 2 is 2888, okay. Then this is 21444, then again 2 7s are, 2 2s are, 2 2s are, then 2, 722 divided by 2 is 3s are, 6s are, 1s are, 361. Now 361 is the square root of 19, 19 19s are, 19 1s are, okay. Now, so pairs which are formed are pair of 2, another pair of 2, and a pair of 19. So this is 2 into 2 into 19, 4 into 19, that is 76. Okay, so Again, we've got the same answer, 76. So these are the two methods by which you can find the square root. Now, the question is that in the prime factorization method, sometimes student gets stuck here in this step. Like 361, it's not divisible by any composite number. So now, because I remember, I have memorized that 361 is the square of 19. So it was easy for me to write it directly. Okay, but sometimes when you don't know by which number is the given number divisible, so in that case, the long division method will help you a lot. Okay, so long division is preferred more than prime factorization. Okay, I'll give you another example. I'll show you. Say for example, I'll give you one number, 7921. 7921. If I want to solve this with the help of prime factorization, it will take me it will consume a lot of time. Why? Because straight away 79 is divisible by only 89. There is no number less than 89 which can completely divide this number. So here, in such cases, I am stuck. So for that, I need to use the method of long division. Long division will be giving me the answer within few seconds. 7921. Okay. So I'll be making pair. Then 8 8s are 64. Which is, because 79 is not a square of any number, so I will have to take a number which is less than 79, closest to it, which is square. It's a perfect square. So this is 1521 remaining. Again, I'll be adding the same number, 16 over here, and this digit should be the same. So 161 into 1 will be far. Okay, so now one thing to remember. Doing this repetitive process, 161 into 1, 162 into 2, you just notice the last digit. Now, one thing I am sure of, that I told you in the earlier slide, that the square of 1 and 9 ends with 1. So, if this is not the answer, my most probable answer would be 169 into 9. Why? Because if I am doing the multiplication with 5, it will end with 5. If I am doing the multiplication, if I am writing here 4, so it will end with 6. Okay? So this method is called the cyclicity. Okay? By the method of cyclicity, you can solve this very quickly. So 169 into 9, 9 9s are 81, 9 6 are 54. 54 plus 8 is 62, and this is 15. So 169 into 9 is 1521, and the remainder is simple. I've got the answer. Okay, so long division will give me a very precise answer within fraction of seconds. So this is how you can find the square and the square root of any number. Okay, I hope you have understood.